Welcome back to the deep dive. We take dense technical stuff and boiled it down for you, fast.
Give you the core insights you need.
Exactly. And today, our mission is tackling, well, a physical problem. Getting high-res video across really big spaces, commercial settings, institutions, that sort of thing.
Big buildings, lots of screens.
Right. So we're digging into the engineering thinking behind professional AV architecture. Specifically, we're looking at these specs for the WolfPack Lite 8x8 1080p HDMI Matrix Switchers.
Okay.
Now look, we're not here to sell you a box. We want to understand the kind of pro-level engineering needed to push, perfect HD video hundreds of feet.
Without losing quality.
And without needing a million cables or power outlets everywhere. It's about the how.
And that logistical challenge, that's really the heart of it. Maybe we should define terms first for anyone new to this.
Good idea.
Yeah.
What is an HDMI matrix switcher?
Okay, think of it as like the traffic control center for your video. It's the brain. It takes multiple inputs. Could be satellite boxes, media players, computers.
8 of them in this case.
Up to 8, yeah. And it lets you send any of those signals to any of the outputs, or even all of them.
Which connect to the TVs or projectors.
Exactly. And this system can handle up to 8 outputs. So an 8x8 matrix, 8 inputs, 8 outputs.
And the key here is routing those signals over standard RJ45 Ethernet cables.
That's the professional difference. It's not your home setup. This is the kind of gear that runs video walls in, say, control rooms or digital signs all over a campus.
Or like a massive sports bar with screens everywhere.
Precisely. That's the infrastructure we're talking about.
Okay, let's zero in on that main challenge then. Distance. Everyone knows standard HDMI cables, they give up pretty quick.
They really do.
What's the limit? Like 25 feet, maybe 30 if you're lucky. After that, the signal just dies.
That's right. It's just physics, really.
Yeah.
HDMI carries a huge amount of data, very high frequency, over a simple copper cable.
The signal gets weaker.
Yeah, attenuation. You lose the high frequencies first. You get things like cable skew, jitter. Basically, the timing gets messed up.
And then black screen. Or weird artifacts.
Exactly. Total signal failure eventually.
Okay, so if HDMI taps out at 25 feet, how on earth do these systems promise perfect 1080p over 450 feet using just regular Ethernet cable? That's huge.
It is. It's a massive jump. And it requires active processing. It's not just passing the signal along.
Active processing, so the box is doing something smart.
Right. Now, the industry often uses something called HD-T for long-distance HDMI.
And the vendor here, HDTV Supply, they're approved for HDB, right? I saw that.
They are, which is important. But the source material highlights their own tech for this specific 1080p distance, LHDT.
LHDT, long HDMI distance technology.
That's the one. And LHDT essentially means the signal is actively managed, it's cleaned up, the timing is fixed, reclocked, all along that 450-foot run.
So it's fighting the signal decay in real time.
Exactly. They're basically promising that after nearly 500 feet over a standard CT6 cable, the picture looks identical to using a short 3-foot HDMI cable.
Wow. Okay, that quality promise is key. But hang on. LHDT, that's proprietary, right? Their own tech?
It appears so, yes, for this specific function.
Doesn't that worry installers? Getting locked into one vendor, what if you need parts later or want to upgrade with different gear? Is that a risk compared to using an open standard like HDBaseD?
That's a really sharp question. It's a constant balancing act for integrators. Cost versus flexibility. Proprietary tech, like LHDT seems to be here, can sometimes hit a specific performance target or price point really well.
So optimized maybe just for 1080p, a super long distance?
Potentially, yeah. A high-performance niche solution. The fact they also are an HDBaseD adopter gives some confidence, shows they know the standards. But yeah, relying on their specific LHDT chip for that 450-foot run, that's definitely something you'd think about for, say, a 20-year plan.
Okay, that makes sense. Now, another interesting bit from the specs, infrastructure flexibility. They recommend CT6 cable.
Which is standard for new installs now, yeah.
But they specifically say this system works perfectly fine with older CT5D cables, too. Oh, that's huge. Seriously, think about retrofit jobs.
Right, building's already wired up.
Exactly. Most places built in the last, 20 years, they already have CT5V running everywhere for computer networks.
Yeah.
If you can use that existing cable for your HD video,
instead of pulling new, expensive stuff,
you save a ton. Labor, materials. It makes upgrading way, way easier. It removes a major barrier.
Okay, so signal integrity over distance, solved by LHDT, works with existing cables. What's the next big challenge? Managing the actual install, the footprint.
Yeah, deployment.
Yeah.
And that brings us to another really smart efficiency feature, PoE, Power over Ethernet.
Ah, right. So explain PoE in this context. If you're putting up, say, 8 TVs in a hospital wing or across a big office.
Or a mall.
Yeah. Normally, you'd need a power outlet behind every single screen for the little receiver box, right?
That's correct. And those screens are often high up, hard to reach.
Running power to all those spots sounds like a massive pain. Expensive, time-consuming, maybe even impossible sometimes with building codes or whatever. It absolutely is. That's where PoE is strategic. The main matrix switch, the central box, it handles the power.
How?
It sends the right voltage, low voltage, down the same Ethernet cable that's carrying the video signal.
No way.
Yeah. So that one cable delivers both the picture and the power needed for the small receiver unit tucked behind the TV.
Okay, that changes things. So no separate power adapter needed at the screen?
None. Think about the benefits. First, you probably don't need a licensed electrician for every single TV location. Huge labor savings.
Its costs way down.
Dramatically.
Right.
Second, safety and compliance are easier. You're mostly dealing with low voltage runs out to the displays.
Makes sense.
And third, maintenance. If something goes wrong with power, you check one central spot, the matrix switch, not 8 different outlets hidden behind TVs.
That's just smart integration, building efficiency right into the system design.
Exactly.
It's baked in. And that streamlined thinking seems to apply to the matrix box itself, too. It's not just one big fixed unit, is it? It's modular, built with cards.
Right. Uses 4 port cards. Input cards, output cards.
Why is that important? Modularity.
It's about budget and scaling. Let's say your client only needs 4 inputs and 4 outputs right now. A 4x4 setup.
Okay.
They don't have to buy the full 8x8 capable chassis and leave slots empty, or buy an oversized fixed box. They can get just the 4x4 configuration.
Which costs less up front. The source mentioned around, what, $350 for a 4x4?
Something like that, yeah. Compared to over $2,000 for the full 8x8. So start smaller. Then later, if they need more, say go up to 8 outputs.
They just buy another 4-port output card.
And slot it in. Boom, you've got a 4x8. Or add an input card for an 8x4. Or both for the full 8x8.
So it grows with the need, less disruption later.
Exactly. The integrator manages inventory better. The client gets a phased rollout if needed. It's tailoring the infrastructure, but with a clear upgrade path.
Okay, systems installed, power's handled, it's scalable. Now, performance, speed. In live situations, command centers, broadcast rooms, switching needs to be fast, right?
Instantaneous, ideally. Any delay is bad.
So what do the specs say? How fast is this thing?
They list an 80 millisecond switching time. And also 80 millisecond latency.
80 milliseconds, is that fast? How does that feel?
For switching video sources, yeah, that's very fast. It's essentially imperceptible to the human eye.
So if an operator switches from camera 1 to camera 2?
The change is seamless.
Yeah.
No visible flicker, no noticeable lag. Which is critical if you're trying to track something important. Keep situational awareness high.
Okay. And latency too, the delay from input to output, also 80 meters. Good. Now what about mixed environments? You know, a client has some brand new 1080p screens, but also some older ones, maybe 720p.
Happens all the time.
If the source is 1080p, what happens when it hits that older 720p screen? Does it just fail?
Good question. That's where resolution scaling comes in. It's built onto the output cards.
So the card itself is smart enough to adjust?
Yes. It reads the display's capabilities. That's called the EDA. And if the display says, I can only handle 720p, the card automatically downscales the 1080p signal to match.
Oh, nice. So one source can feed multiple screens, even if they have different resolutions.
Exactly. The system handles the compatibility.
Yeah.
The operator doesn't have to worry about it. Makes the whole setup much more robust.
Very useful. And audio, is that handled too?
Yep. The source mentions separate audio provided on all cards, which is important for pro installs.
Why separate? Isn't the audio usually embedded in the HDMI?
It is, but in a professional setting, you rarely want to use the TV speakers. You want to send that audio to a proper sound system, amplifiers, speakers.
So the card lets you pull the audio out of the HDMI stream.
Precisely. De-embed it.
Yeah.
Then you can route it independently through a high-quality audio system. Much more control, much better sound.
Okay, signal distance, power, scaling, audio. We've covered a lot. How does someone actually control this whole system, manage the switching?
You need options there, definitely. And they provide them. The source lists dedicated apps.
Like for a phone or tablet.
Appreciably, yeah. Also a WEB GUI.
So a graphical interface you access through a web browser on a computer?
Right. User-friendly, point-and-click control, and of course the traditional buttons on the front panel of the Matrix itself.
Standard stuff. But you mentioned some more advanced features earlier, things that make it more than just a router.
Ah, yes. This is where it gets really interesting. Free video wall processing and an optional quad view card.
Okay, hold on. Free video wall processing, what does that mean? Video wall processors are usually separate, expensive boxes, aren't they?
They are, often costing thousands just for that one function. But here, it seems that capability is built into the Matrix output cards.
So the switcher itself can create a video wall.
It looks like it. It can take one input signal and intelligently split it, crop it, scale it across multiple displays, say 4 screens arranged in a 2x2 grid to make one giant coherent image.
Does it handle the gaps between the screens? The bezels?
Good video wall processing does, yes, and compensates for the bezels so the image looks continuous. This turns the matrix from just routing signals into actively managing the visual layout. That's huge value.
Wow, okay. And the quad view card, what's that?
That lets you take 4 different input signals and show them all simultaneously on a single display, usually divided into 4 quadrants.
Ah, like for a security monitoring station.
Exactly. Perfect example. An operator needs to keep eyes on 4 different camera feeds constantly. Instead of needing 4 separate monitors, they can see all 4 on one screen using the quad view card. Really essential in some environments.
That level of functionality, it explains why you'd want a supplier with a solid track record. This isn't just throwaway tech.
No, it's infrastructure, designed to last years.
And the source mentioned HDTV Supply's background.
Yeah, 24 years globally, certified since 2003, and that hdbased.org adopter status we talked about.
So that pedigree matters. It tells the installer, okay, even if they're using some proprietary tech like LHDT for one specific thing,
They still understand and adhere to the broader industry standards. It reduces the perceived risk of the investment.
Okay, so let's wrap this up. If we boil down everything we learned about how pros beat distance and complexity in AV, what are the main takeaways?
I'd say 3 things. First, overcoming physics takes specific active engineering. Getting 1080p reliably over 450 feet of network cable, that needs smart, active processing like LHTT to fight signal loss.
Right, it's not passive.
Not at all. Second, installation efficiency is absolutely key. Using PoE to send power down the data cable, that saves massive time, cost, and complexity. It centralizes power management.
Streamlines everything.
Totally. And third, the modern AV matrix isn't just a simple signal router anymore. It's becoming a content management platform.
With features like the modular cards.
Modularity, resolution scaling, and especially that built-in video wall processing. It makes the system adaptable, scalable, and capable of complex visual setups.
So looking at the specific tech really shows a bigger pattern, doesn't it? Using smart engineering to push lots of data over existing standard infrastructure.
Yeah, repurposing what's already there.
It definitely makes you think. If standard network cables CT5E and CD6, which are everywhere, can handle flawless HD video over these crazy distances thanks to tech like LHDT, well, what else could run over standard Ethernet?
Good question.
You know, think about other industries that rely on expensive, specialized copper or fiber right now, maybe high-power EV charging or connections inside data units. Could they be due for a similar long-distance Ethernet-based revolution using clever active processing? Something to chew on.